So this kind of question that we've just done part A and part B, but I want to talk about part C, which talks about whether or not the parcel will move. They love these kind of questions where they then say, determine whether the box will move. And there's a particular way that we should set these kind of questions out, which is why I wanted to make a big deal of this bit. Just wanted to quickly say what we did in this first part of the question. It was one of those very standard kinds of questions where they said it's in limiting equilibrium, about to slip up the plane, hence us putting the friction going down. They told us what the normal reaction was and what the weight was. If you put G in there, obviously you've made a mistake, because that would have been if they told you the maths. And we've worked out the value of P and we've worked out the value of mu just by doing those different things of resolving that we've got here. They then say, though, that the force is going to be removed, and we need to determine whether the parcel is going to slide down or slide up, or what's going to happen to that particular parcel. Now, you have to be really careful in this kind of question, because if you move the force P, can you tell me something that will change? R will change, because if you remove P over here, clearly, it's not going to be 18 up there anymore. R is going to change. What else is going to change if R is going to change? That won't change because R is going to change. It will change, but that won't change because R is changing. The value of the friction will change, okay? If R changes, the maximum value the friction can take will change. And Luke, what else will change if P is removed? Now it's the direction of the friction. Do you see how it didn't relate to my question? The direction of the friction is also going to change, because if you remove that pushing force P, it's no longer going to be wanting to slip up the plane. It's going to be trying to slip down the plane. So the friction is going to want to be going in the other direction. So I'm going to draw another diagram for part C of this question, because you can see it's a 5-mark question. That sounds like it's going to be a bit more demanding. So if I just do a little small version of the diagram that I've got here, I've got a parcel with a normal reaction, and I've got its weight. Its weight won't have changed. It will still be 10, right? But this time, we know that there's going to be some friction coming up to the right here. Now, I'm not going to actually say what that friction is mu r. Why am I not saying that the friction is mu r this time? Because I don't know that it's in limiting equilibrium. I just want to find out what that friction is. So we need to do some more calculations to actually figure out what's going on here. So this is for part C of the question. Now because it's actually saying determine whether or not the parcel moves. So this value of the friction, if it's not going to move, it might not even be in limiting equilibrium. It could just be sat there, and the friction might not have reached its maximum. So if I draw another one of those extra diagrams that we like to do, we've got R that's going upwards, and if we split those into two forces, what's the one coming out the bottom? It's still the same as before, 10 cos 30, and then we have 10 sine 30, and then to the right we have the friction. Now, to determine whether it will move, what are we interested in actually finding out here? Okay, yeah, we are going to need to find out what it is. We're going to need to find out what the maximum value that the friction can take is. And then, after we find out what that threshold is, because actually Hamza told me that word threshold, which I really like. Once we find out what that maximum threshold is, what are we going to look at on our diagram to decide whether it will move or not? Less than or bigger than what? Yeah, I guess so. I suppose what I really want to think about is 10 sine 30. That's the force that's trying to make it move, right? That's the force that's trying to drag it down the slope. So I want to know, is 10 sine 30 going to be able to go bigger beyond that threshold of the maximum friction? If so, it will move. If it doesn't go beyond that threshold, it's not going to move. So we're going to very quickly calculate. I'll just block up that bit here. We're going to calculate now what the maximum value of the friction is. So we know that the normal reaction is 10 cos 30, and so the friction max is going to be mu r, which is 0.62 multiplied by 10 cos 30. And I'm interested to get this as a number now, just because I think that's going to make it a little bit easier to compare. 5.38 newtons to 3 significant figures. And I guess we also want to find out what this 10 sine 30 is, which is the thing that's moving out. What is 10 sine 30? Okay, good. So we know that this 10 sine 30 here is 5. So So because 10 sine 30 is less than the friction maximum, and you could say that in a number of ways. You could say because 5 is less than 5.38, we need to have that little sentence say, because this one is less than this, what will happen? It will not move, okay? Because the force that's trying to drag it down the slope cannot get bigger than the threshold. And so when you try and explain that, you just need to say, because this force is less than the friction maximum, the box will not move. So if they ever ask you to try and determine whether a box moves or not, you need to redraw the diagram, because if you redraw that diagram, potentially the value of R is going to change, which means the friction is going to change, which means all these other things might be changing. And you then need to think about, is the force that's trying to make it move down, is that force that's trying to make it move down, is it going to beat the threshold? If so, it will move. If it doesn't beat the threshold, then it will not move. Okay? So you're going to do some questions for me, some exam-style questions now. No, we'll do some bits on dynamics, I think. We'll do this next little example, and then we'll do some exam questions instead. Okay? So this is basically exactly the same as everything that we've done previously. Does anyone need me to go back to that previous slide to write it down still? Yeah? Just going to stop that there.